Kyle Schofield, Daniel Ross, Brian Sofley, and Adam Bouknight. Project was a mobile irrigation and pump system analysis training. Got a couple objectives. Basically, project goals in mind was to teach future students in the AgMed program how irrigation systems work, along with pumps, and after that, basically show how fertigation systems work. We have a little section on pump that you'll actually see later on the trail, clear PVC so you can see the injection take place. Two different forms, an injection pump and a Venturi injector.
So one of the major theoretical things that we're trying to show is friction loss. And this is the equation, Hazen-Williams equation, to calculate friction loss for actual stick of pipe. But one of the major things that we ran into is there's about 1,000 different fittings in our design, and there's a lot of pressure loss between those, elbows and T's, which is a loss of energy. And so that's a major thing we're going to show through our system. We have different pressure gauges throughout the system to show. Okay, right here at the pump it's 35 psi, and here at the end of the system, once you travel through various fittings and T's, what that friction loss and energy loss actually is. This is just a chart to calculate the pipe size. We went with a 1-inch pipe with our flows. Order velocity at around 5 feet per second. In order to attain that with the flows that our pumps were putting out, we had to go with a 1-inch pipe. And then both the pumps we used were centrifugal pumps. One of them is set up so it could be used as a jet pump, but we're just using it as a centrifugal pump. One of them's half horsepower and the other is 1/3. And we also have the system set up so we can run pumps individually. We can also run them parallel through one output, and actually ran it first time in series. And when you run it in series, it's got some extremely high pressure, and when you run parallel, it just increases the flow. And here's the schematic. When we're designing the system, we had a general concept of what we wanted to do. We had to adjust it a little bit. Once we got to figure out how everything would go in the trailer. We added a few things, but here's the general schematic of the design. And then here's the two pump curves for our two pumps. This is the 1/3 horsepower here. We're running about, it depends on, we have several different irrigation systems coming off the back of it. And so depending on which irrigation system we have and what kind of flows and which pump we're running series or parallel, kind of defines where on the pump curve the system is running. And we actually calculate our pump flows for the system, and we just used a 5-gallon bucket and filled it up for a few seconds, pulled it out, and then measured with a graduated cylinder how much water was in the bucket, and then use that to calculate the pump flows for each of them.
These are our two different pumps we use. This is the half horsepower pump. It's what runs the different fertigation systems on it, and it's controlled by an irrigation system controller. And then that would be the 1/3 horsepower. The half horsepower is run based on a pressure switch and an actual manual switch, where the 1/3 is run by the irrigation system controller. And the half horsepower is the one that can be set up to be used as a jet pump. The two different types of fertigation systems we have an injection style pump, which it actually has a pump you actually have to provide power to pump the fertilizer into the system. Where the Venturi, it actually uses a pressure differential to draw the fertilizer out of a bucket into the system. And we also have a bladder tank on there, which when it fills up to a certain pressure, the pressure switch down here will actually turn the pump off. And then down the line, whenever this pressure drops back, whenever you have something flowing out, it'll drop below 30 psi and cut the pump back on to give you extra water when you need it. And this cuts it off when it hits 50 psi. We also have two different types of filters. We have a disc filter and a screen filter. This being the disc filter, and that being the screen. The screen filter can be back flushed to clean it out, which is done just by twisting the top, and it flushes all your contaminants out through the bottom. And these can be run in both at the same time or just individually.
Hi, I'm going a little bit about future work. As of right now, just to kind of demonstrate what we're going to be doing in the future, we do have some different options set up outside we'll show you. But in the back, we have some, we don't have a picture of it, but on the right side of the trailer there's some banjo connectors, easily connect your pipe and whatnot. Right now, coming out of the spigot, there's a separator that has 4 different lines coming out of it, and there's actually 3 different types of drips. There's a drip hose, your drip tape, and another drip hose that actually has small sprinkler heads coming off of it, little spray heads. Off of the banjos, one of them's coming up to this PVC pipe, and before this is actually your electric valves, and you can either turn on going straight to this pop-up sprinkler, or you can go right to 2 more pop-up sprinklers. These 2 are spray heads. There's 2 of them on this line of spray heads, and if you turn the other valve on, it gets to 2 pop-up sprinklers. The other banjo goes up to it has 3 T's in it. It has 3 lines coming out, and there's 2 more drip kind of systems. Just to kind of show you what we can do with it, with the future, what Dr. Privette, what he decides, what he wants to teach with, whether he wants to do, you know, more pipe, pop-up heads, whether he wants to do spray heads, drip, whatever his learning style wants to be.
Here we have general overhead picture of the actual trailer. Pretty much shows the direction of flow. All these little red check marks, they're actually the check valves. Basically prevents backflow through the system. Going off the 2 different pumps, basically you get the output right up there and there. It goes through the pump and back down either way. This one right here, if you're using Venturi, it'll go around, have the injection here, and go back around. If not, you can turn the valve and it just goes straight through. This one down here goes through here, pressure tank, back down, and then right here is actually our return. It will go back up in there and then send it right back into the tank if you're not using any sprinklers.
Our timer is set up towards the back of the trailer, and the timer will go down, come here to the control box. The generator is supplying power, and that timer will turn that power onto that pump, and that's how that works. And then the switch is here for this pump. And
we have 2 generators powering our trailer, 1 for each pump. They're Honda EU 2000 generators, each put out 2,000 watts at about 13.3 amps. We chose those because they're the quietest generators you can pretty much buy. They're also very good on gas. They're very quiet. You can have both of them running and still talk easily over them. And they're bolted down and locked down so they can't be stolen very easily. These are a few of our relief valves in our system. This first one is an air relief valve. It allows the air to go out there before it gets to the rest of the system. We have a low pressure drain, which basically prevents all the water from going back, if you had a well system, into the well. We just put that on there to demonstrate if it was set up for a well pump. We have a flow regulator on our 1/2 horsepower side, just to demonstrate that it can be restricted down to a consistent flow. We also have 2 pressure regulators on the system, set at 75 psi, to keep the pressure under 75, so it won't bust the pipes or anything if it does get restricted somewhere.
This is beforehand. This is our trailer, 5x10 trailer. It had tables, had a whole bunch of different stuff mounted on it. Basically stripped the whole trailer off. The only thing left was the tank. Is a 125-gallon tank. Reason we kept it there because it's right over the axles. That's where most of our weight is. So we stripped that down, took everything off of it. And then the next slide is our after picture. And you can tell the tank is still there. We put our generators, our 2 pumps. It's a little bit different than our first plan because, like I said, to fit everything on the 5x10 trailer, we had to, rig it up a little bit. Also set down stainless steel plate so you can, aluminum plate, so you can see where everything is instead of just looking at wood. It's kind of easier to, see where all your pieces are. You can see through your see-through pipe on the side, and it's also just easier to look at. Here's our budget. Our predicted budget in the beginning, our estimated was around $9 grand. And we actually came under that by almost 3,000. And we had 6,000, 3072. The aim of our project was to create the fully functioning system, complete with your pumps, your control valves, filters, fertigation system, The final project will be able to be attached to various irrigation applications like I talked about earlier, whether you want to drip tape or whatnot, and it demonstrates the requirements needed to run each system. For conclusion, we created a mobile irrigation and pump system analysis trainer for future, especially for Dr. Privette, so you can show us AgMech classes. They can learn about the flows, the frictions, application methods, power requirement, application methods meaning, your drip, your pop-up sprinklers, and all that good stuff.
Then we have a kind of special thanks. Brian Smith, who's a friend of Dr. Privette's, a friend of the program here at AgMech, pretty much helped us design more specific parts. I mean, we all know more or less a little bit, but some of the stuff is pretty complex, and in putting it together, he kind of helped us through it, along with Dr. Privette. I want to thank Hunter for donating the trailer to us. And then we got all of our equipment through John Bozeman, WP Law, another friend of Dr. Privette's. And then Northwestern Supply in Seneca, we pretty much raided their whole store of fittings and valves and all sorts of stuff there.
So here's our system right here. When you get a chance, get up close and you can look at all the components, but we're going to run it here in a few minutes first and show how it works, and we can get up close and look at everything. But hey, shoot. Heads up. These things should be spraying towards the wall, but got soaked earlier trying to set them off, so might be spraying some water this way, so just heads up. We'll run it first. We'll run. Which one do you want to run first?
I do that.
All right, this is our half horsepower here.
Blow up. So that fitted.
Oh, so sorry. You want to run the third horsepower. Venturi to the injector. Rotor springs first. They should get you wet. It automatically turns the pressure rises. We've actually got
The timer has different zones. That's what the electronic valves are. You see where the wires come from. And each one is different zones. That's what you plug into your timer. Different types of spray heads.
So y'all had 402, and a 3-hour lab on the NP rotator. We've got 4 spray heads, 2 rotary heads over there. So 2 spray heads. We have rotaries are the same, and then we have 2 different types of spray heads.
Hard to tell on that one.
More like domestic type system, something to put the hose in. Run off down, we got one line for six, put those, bitters plug into it. Run off the hose there. Right now, I know you can't really see it, but you have your spray heads coming off the zip line. There's going to be your drip head.
Military work, you have to have a pressure differential, which you do using the gate valve. And you just basically You just tighten this down till you get the pressure differential you want.
As you can see, it's starting to go down the line.
It's hard to tell color change.
And you can start seeing a little blue tint to it. Since there's so much flow going through it, you can't get a huge coloring in it.
Aluminum, I can't see your tube.
Yeah, so you can see it starting to turn blue.
Oh, there we go.
There it goes. And then we could hook them up in parallel and series, but time constraint, it'll take a little while. The injector pump is pretty neat, but it takes a long time. For
Yeah, it takes forever. It takes probably 20 minutes to get it primed and actually flowing.
So I won't show it, but that's it. There's a pressure tank over here. On this side, the cycle stop and all that. But
And that one will automatically cut off when it gets 50 psi built up in the line, and will turn back on when it gets 30 psi built up, or when it drops back below 30 psi. And you can just have a master switch up here. We can turn it on or off.
Yeah, this is the master switch for that second generator that runs the 1/2 pump. The 1/3 pump, the timer runs up to the box. Generator gives the box power, and then the timer will turn that on, the switch on to turn on the pump.
Yeah, that's actually just a relay. Is all it is, because the irrigation controller doesn't have enough power to power the pump. So we run it through relays, and the relay pulls power from the generator.